Okay, let's talk about the homework that goes along with this. Now that you've discovered the chart, and you should have gone through this with me and figured out where we are coming up with each of these. If you've lived through this, you're going to have to use a little bit of reasoning and some logic, and you can solve these. All right. Now, something to note here: this chart was only for regular. These numbers right here were for regular polygons. However, this column, it works for any polygon. What I mean by that is that pentagon right there, 1, 2, 3, 4, 5, that pentagon is not perfectly shaped. It's not perfectly symmetric anymore. But this thing about pentagons still applies. The 540, I know that right there adds up to 540, just because I can look back here on my chart. Okay, so I can just take work right here, and I could subtract all those off. Minus 103, minus 85, minus 121, minus 68, and see what's left, because I know that adds up to 540. Okay, that's pretty straightforward. We can also take this same argument right here, and let's see. This looks a little odd here, but I think that x degree goes for that one, and that x degree goes for that one. That's 2x degrees. Okay, let's see how many sides we got. 1, 2, 3, 4, 5. This has 6 sides. This is a hexagon. It's not a perfect hexagon, but I do know, according to this right here, that my hexagons add up to 720. Now, again, you're not going to have this chart during the test. I don't think. I need to think that over. But you should be able to do this. You should just know a hexagon. I can say, oh, well, it's 4 triangles. 6 minus 2 is 4 times 180. Oh, yeah, it's 720. Okay, so I can do this problem right here. I can set up a long equation. X plus 2x plus 3x minus 17 plus x plus 10 plus x plus 10 all equals, how much the hexagons add up to? 720. That's the key part of this. From here, you can do the algebra, combine like terms and all that mess. Okay, so let's do one down here. How about this? Find the measure of an interior angle of a regular dodecagon. Well, a dodecagon, you probably don't know that. That means it's a 12-gon. So let's write that in. A 12-sided figure, interior angle. So let's think. If I was going to do it, if I had a 12-gon, and they're really hard to draw, so I won't draw that. But I know that if I did draw one of these and I drew in all the diagonals, how many diagonals would be in there? You ought to be able to answer this. 10 diagonals. That's your n minus 2. Put a 12 in there and you get 10. And that 10, not diagonals, I said diagonals. You would draw in, this would be the number of triangles after you drew in the diagonals. I apologize. This is the number of triangles. 10 triangles. 10 triangles at 180 each would be 1,800. That's the measure. That's the sum. That's the sum of all of them. The sum of all. So if there's 1,800 degrees in there, and there are 12 angles, so now we can find the measure of an interior. That's singular, right? That's just one interior angle. So I'm going to take 1,800 and divide it by 12. We'll see what we get. 150 degrees. Each angle in there would be 150 degrees. Done. Okay, you have to remember back to how we discovered the numbers on the chart. And I apologize for saying that wrong. I said diagonal, I meant triangle. This is the number of triangles. If there's 12 sides, there's 10 triangles. Okay? All right. How about finding the number of sides? Could we do this? All right, so I've got a polygon. I'm not going to attempt to draw all of it, but I do know that each interior angle is 160 degrees. These are 160 all the way around. I don't know how many sides there are, so I really don't know what it adds up to. And it's asking me for the number of sides. So this is where you've got to be smart. We've got to strategize here. The interior degrees always is changing, so I can't attack this from this point of view. This end. I do know something that's constant, and that's this right here. It's 360. So let's convert this to an exterior angle problem. If those are 160, how much is each one? 20. According to my linear pair rule, 20. So then now the question becomes, how many 20s does it take to add up to 360? Well, I would simply do this, 360 divided by 20. And it would take 18 of them. And since there's 18 exterior angles, that also means there's 18 sides. Those are always the same. Done. Okay. Let's do another. Find the number of sides if the polygon of the sum interior is 2520. Okay. Let's think here. 2520. So I have a polygon. I don't know how many sides there are. I'm just going to draw some sides and stop again. I know that all those added together are 2520. So how am I going to figure out the number of sides if I don't? Okay, so here's the deal. You have to think about where'd this number come from, 2,520. It came from a bunch of triangles. So how many triangles does it take to come up with this? Well, I would divide by 180. How many triangles? It should be a whole number. If not, yeah, it's 14. 14 triangles. So this represents 14 triangles inside there, which means, see if you can do this, how many sides are there? So if you're thinking about the n minus 2, you're correct. However, you have to go backwards. So if there's 4 triangles, there's 6 sides. 5 triangles, there's 7 sides. You have to add the 2 back. So that means it would be a 16 gone. Okay. You can do the homework here. There's lots of questions on these. These, I think, should be self-explanatory because those are exterior. They have some markings on there as well. Exteriors all sum to 360. And let me just show you, see if I still have this pulled up. In your packet, there are a couple of links down here that are pretty helpful. This is one of them. So this is, I think it's just a hexagon. And you can see where you can move this around and play with it. Maybe. It's not letting me move any of them. How about this? Let's try going to a, there we go. So I can move that around. I could add more sides. There's the 7-sided figure that equals 900. I could do 8, 9, 10. I mean, you could keep going here. And of course, you're going to see that this eventually, gets closer and closer to looking like a circle. It's kind of fun to play with. One thing you will notice is that none of these will ever get above 180. There's no way they can. And that's an idea of about infinity, things approaching infinity. It'll never get there. Because if it is 180, this would no longer be a polygon. Okay, so that was one thing that's kind of added in here. Notice the other one looks like this. This was a demonstration of your, it's not going to let me do that full screen. This was a demonstration of your exterior angles, and even it can just be weird. There's still 5 sides, but up here it's measuring them and showing you that they're never going to change. Like that 360 just stays solid right there. It does not change. Even if I add sides, still adds to 360. The angles got a little smaller, but it still adds to 360. You could play with that, see what it means to be a negative degree angle, which you could argue that the way that's doing it. It's still going to sum to 360, even if we keep adding sides. All right, 360. Anyway, both of those are pretty good demonstrators, so I'd encourage you to play around with those. Hope this helps with the homework.